the trend is just the way to remember, like in general, as you go left to right, ionization energy increases. But if they were to give you two atoms, atom A and atom B, and they said, okay, the ionization of A is 400 kilojoules per mole, and B is 600 kilojoules per mole. Explain why. Explain why there's a difference in the electromagnetic or ionization energy. So let's talk about it. What is ionization energy? Energy required to remove an electron. So there's really two major things that affect that. Go.
The amount of electrons that are like shells.
Good. More shells typically mean less ionization energy because they're further away from the nucleus. Good. What else dictates that number?
Number of protons.
Yeah, the Coulombic force between the nucleus and the electrons, right? So if you have a strong Coulombic force, meaning a lot of protons, or effective nuclear charge, another way to say that. So if you have a strong or high effective nuclear charge, that's going to keep them close. And then of course there's going to be the kind of hard, weird questions where you need to draw out the electron configuration. And I will tell you this, that if you have something that looks like this versus something that looks like this often can increase electron repulsion. So if this element, even though it has one more proton, right? So again, it doesn't matter what it is. You know, you could say nitrogen and oxygen. All right, I don't want to say something that's wrong, but if you have oxygen and nitrogen here, this has 7 protons, this has 8. So you would expect that 8.
I wasn't expecting you to be this busy.
Yeah, I got review class. So and I'm recording, so.
Oh, that's a great time to pop in then. I picked a great moment.
Yeah.
Do you have the answers to all those?
Yeah.
I just want to see, like, I know I didn't win, but I want to see.
There's the answers.
Okay, yeah, I want to see, like, what they actually were.
Here, do you want to compare it to yours? You can double check. I was going to double check them to make sure, but no one's even close, except for Galvin and Goldel.
Okay.
I already double checked
I think
theirs.
you just passed mine.
Did I? Yeah, you're Gary, right?
I am Gary. For most of the day.
I actually had tears coming out of my eyes when I opened that up. I was in ISS just grading stuff, and I just was like, oh, I checked my phone a while. I checked to open it up.
It's so dumb.
What? I don't know where you found that.
I don't know. I was
I
crying.
need to show the world.
Yes.
So 8 protons, 7 protons. You would expect this to have a higher ionization energy. However, if the question said explain why this ionization energy is lower, you would have to figure out, okay, well they both have 2 shells. This one should keep the electron tighter, but it doesn't, and that's because there might be some electron repulsion here. So that's where the AP gets confusing. So things that you know, right, the number of shells and the effective nuclear charge, but then they're going to give you a question where that doesn't really make sense, and you have to still figure it out.
How do you know if it's electron repulsion?
You have to draw it out.
Okay. What do you mean? Oh, just like that.
Yeah, if they're close to each other, and typically these are multiple choice. So if you feel confident you understand ionization energy and how it's affected, then you should be able to figure it out with the multiple choice. I think you'd be fine. But that's just another way to kind of think of it. Radius factors in too, right? The radius is related to that. If you have a strong Coulombic force.
Should do that again next year. That was fun.
Yeah, it was fun.
That was cool.
So if you have a strong Coulombic force, your radius should be smaller, right? Weaker Coulombic force should be larger, right? So that's really going left to right. We're talking about ions, right? So let's talk about lattice energy. So that is another thing on my list. So if you have NaCl versus NaO, right? The question might say, okay. Actually, they would just do this. They would say, okay, you have these two, they give you the lattice energy. I don't know, 1,200 and 1,400 kilojoules per mole. Explain why. Right? So then this is still related to the trends. Coulombic force, ions, radius, that all factors in.
Yeah, should be Na2O.
Yeah, I'm sorry. Yeah, maybe they wouldn't actually give that to you because that would throw. So they'd want to keep the same ratio. But look, it doesn't matter. point still is going to be hopefully received here.
Which one's lattice?
And actually here, you know what, since we're just reviewing here, if it was MgO, it would be like 2800. So if they gave you lattice energy, which is the energy to break apart ions in an ionic crystal, technically it's 1 mole of ionic crystal as a vapor, and it dissociates. That wasn't like, that was choppy, but that's what it means. So, what's going on here?
What's the question?
Why does this have the highest lattice energy? Meaning, why does it take the most energy to rip this apart? We can talk about this out loud to save some time, I guess. You don't have to write it down. Again, so the reason I'm bringing this up now is Coulombic force, ions, radius, ionization, all that stuff factors in a lot of different questions, whether you may realize it or not at the time when you're learning. So what does this have to do with forces and charges? Plus, that's only with covalent.
There's more,
These technically don't form bonds. It's just a really, really strong Coulombic force. That's what ionic is. There's two things that affect lattice energy. First, magnitude of charge. What's that? +1, +2, -1, -2, +3, -3. So how much charge there is. So the bigger the number, the more concentrated the charge, the more charge, so it's like a stronger magnet, think it that way. So bigger charge, it's going to be more attracted to each other. That probably makes sense. What's the other thing? This is the analogy I use. If I took those two basketballs and I put them together, the center of both basketballs would be pretty far apart, but if I put these two together, the centers are really close together. So what is that? What's the other thing? Magnitude of charge and basketball versus this thing. Radius.
Oh, radius.
Radius, which is dictated by what we just talked about, Coulombic force, pulling in. So Mg plus 2 has how many shells?
3.
Can you actually close the door? Middle school kids got middle school. What are they doing in our hallway? What?
Exactly
Three what?
3, I don't know.
I don't even know what to ask. Three what? That's what I asked.
How many levels?
Oh, how many shells here?
Yeah, 3.
I was focused on that. You said 3, and I'm like, okay, 4.
I said 3.
Two!
I like knew the
Two
answer,
shells.
but I forgot what
Two
you
shells.
asked.
Oh, yeah.
1s2, 2s2,
Whatever.
2p6. It
Yeah.
loses the 3s2. All right. So this has 2 shells. Okay. All right. It also has 12 protons. So the moral of the story is, Mg is a smaller rate. Mg plus 2.
Wait, why does Mg plus 2 lose the 3s?
Because it lost 2 electrons. It's Mg plus 2. Mg.
Oh, okay.
1s2, 2s2, 2p6. You need to know a little bit about this. There's hybridization. There's 1 or 2 hybridization questions, but it pertains to organics. But that's what most of our examples were, like single bond. I know I'm jumping around, but I'm thinking of it, so I'm going to tell you. Single bonds, remember what the hybridization is? Like on carbon? All single bonds?
Oh,
This
that's
thing?
SP.
SP3.
Oh,
Just 1 double bond.
SP2.
SP2, 2 double bonds. SP or
S-
a triple bond is SP. Okay, if you remember that, you should be in good shape. I don't think you have to explain it. It's just kind of like picking it out. All right, so back to this. Mg plus 2 loses those 2.
Yeah, yeah.
All right, Mg plus 2 is smaller radius than Na plus 1, because Na plus 1 has 11. They both have 10 electrons. Isoelectronic. They both have 10 electrons. They both are 1s2, 2s2, 2p6. But because it has one more proton, greater effective nuclear charge, smaller radius. Since it's smaller, it can get really close to the oxygen. That's the other thing. So the magnitude of charge and how close can the ions get to each other. The closer they get, the stronger their attraction. So you want high charge, small ions, small radius. And that's going to suck them together. So NaCl would have the lowest number. because Cl is a lot bigger than oxygen, because it has a whole nother shell. So if you understand the concept of like 2 basketballs or beach balls or 2 marbles, that that can visualize it for you. That helps, because I know some of this, a lot of it's overwhelming, a lot to remember. But it's good. It's why we review. So you say, oh, I remember that word. I remember talking about this, and then there you go. All right. What else did that lead me to here? I'm trying to. So you guys said you were good at PES. That's the graph with the spikes.
Yeah.
And like for this, 2p6 would have a higher spike than 2s2, but these would be closer to the nucleus, so a higher binding energy.
Or is it going to give us
Well,
one and we have to read it?
I guess I'm sorry, I'm not going to be that.
Okay.
I'm not going to tell you too much. Just you need to be able to.
We have to know the heights and then the before.
How about this? If I give you the graph, you need to be able to read it, and if I give you one of these, you need to be able to draw it.
Okay.
Kind of the same scale.
You're
Yep.
didn't answer your question.
You're welcome. I talked about solubility rules the other day. Review those, because there's PPT equations, there's net ionic equations, so you need to know what ions combine to make a solid, what ions don't. See, there's certain things you're gonna think.
Wait,
I'm.
What? You went over that the other day?
Yeah, last review class. We talked about we did a net ionic equation on the board, and we did limiting with it.
Yeah, you did that.
And I said.
That's solubility.
And I said, I'm not going to go through all the solubility rules, but you need to know
I
them.
watched it yesterday. Okay.
So again, I'm not going to sit here and go over something you can study. You don't need me for that. Just go through those solubility rules. Try and remember as many as you can. There's like groups to it, right? Like group 1 always dissolves. Hydroxide doesn't dissolve very often. Things like that. You can remember kind of general ideas. No, I don't expect you to memorize everything. You're not going to get everything right anyway. You're not going to get every single question right. But the more of these like general things you remember, it applies to more than one type of question. So like these trends and these ions and radiant, it really helps answer multiple questions. So solubility is one of those things. It helps you with multiple types of questions. Talked about that. All right. Hybridization. Oh, there is a chromatography question. Paper chromatography, I'll tell you. So where the ink moves up, and there's different levels. Like if the ink comes out lower or higher, what does that mean? And so remember, if it travels further up, what does that mean?
It's more attracted to the paper. No, water.
The solvent than the paper, right? If it comes out very soon, that means it's really attracted to the paper. Yeah. All right, I'm just gonna, this is again something I'm gonna tell you, and I'll kind of just draw it real quick, but I want you to kind of review this either in your book, notes. I have things on my website, pictures, graphs, all this stuff is on there somewhere, but you guys remember this type of graph? And this is the internuclear distance.
I hate these.
And this is energy.
I don't even remember
This is,
like
so if this was hydrogen, I don't think I drew this exact. This would be higher up.
This is where the ball comes down.
Yeah.
And it's
So yeah, if you have here and here, these are 2 hydrogen atoms. They will, if they're really far apart, they can't bond. They get too close together, they can't bond. So right down here is the Goldilocks region or whatever. So that region, and again, I'm being a little vague because I want you to put some time in on your own. I think that'll help you kind of learn stuff again or relearn it. But this is what happens when all covalent bonds form. They get too close, they repel. That's too much energy. So I guess, if you put them right on top of each other, that's too much energy. And if they're too far apart, they don't bond. It's where they're just right and they release energy, right? When bonds form, they get rid of energy. So the energy is going to be the lowest where the 2 atoms find the happy medium. What do you mean happy medium? Well, you have the nucleus, which is attracted to the other one's electron, and and that's an attractive force, but when they get too close, the electrons repel each other, and then ultimately the protons will repel. So there's, again, like a happy medium. Where is the equilibrium or balance between those forces of opposite charges and then like charges? And that's what this graph shows. All diatomic elements have this. I guess technically, even though I've never seen it, every covalent molecule would have this. It's like the happy spot where it's going to form a bond.
What is that graph called?
I just call it the internuclear. I actually don't know. The internuclear distance graph, the bonding graph, the bond energy graph.
Wait, what kind of questions will we get? Regarding this? This was the cat. Sorry.
Hey, that's yeah. You know, you ask what you can ask for. I just was talking to the guy for our banquet. I said, "Come on, can you take $2 off throwing matzo sticks?" And he's like, "Nope." So you gotta do what you gotta do. You try.
Wait, they're not
like
the
the
$1.
They are. We have to pay $2 per person for them, and that's because I'm pretty sure you guys eat like 30.
So many? Oh,
Yeah.
so
So
good.
when we come in, they have to have like 2,000 on hand. So I can't blame them. Potential energy versus internuclear distance graph. That's what I titled it here.
Okay.
Wait,
you
what?
said-
Potential energy versus internuclear distance. That if you go on my website, which I guess I haven't really told you, I'm telling you now. Click on these videos and these images, and it'll all come rushing back to you. You're like, oh, I remember this now.
That's what you want.
That's what I hope.
Wait, question.
Yeah.
So you say that it's like for all covalents. What about the covalents that aren't the same though? Like that aren't that covalent?
I've never seen that. I'm just saying I'm sure they exist. I just haven't seen them.
So
So we're just gonna worry about the diatomic.
Yeah.
And remember that one on that quiz where there were 3 of them?
And we all got it wrong, yeah.
Wait, did everyone get it wrong?
Yeah, I'm pretty sure.
I don't
Cool.
even know.
Yeah, but that was because of the triple double single bond, and the
Yeah.
triple bond's the closest,
Oh, yeah.
and loses the
Yeah.
most energy, most stable.
Will
It's
it be a
not going to
question
be a
like that?
question like that.
Okay,
No.
thank you.
You just need to be able to explain what I just went over. If they're too close, obviously they repel. If they're too far, they can't attract. So there's just right, but there's two forces at work here: the attraction of the opposite charges, and then the repulsion of the like charges. That's the balance. The other one is
Wait, if they're too far, what will they do? What?
they can't bond if they're too
They
far.
can't.
It's like holding magnets too far away. They won't feel the attraction. The other one is the Maxwell distribution curve. It looks like this.
Do we need to know the names?
Nope. Looks like that. This is number of molecules. This is, I'm drawing a blank right now.
Like something.
Yeah, it's either speed. There's 2 different ones. That's why it's speed. Good. Yeah, speed. And if you have 2 temperatures, yeah. So this would be like T1 and this would be T2.
We never went over this.
Wait, I've
We
never
did-
seen
we
this
definitely
in my life.
did.
We've gone over it like at least twice. Actually, I know I have. So
At
take
least
that.
Did you just say take that?
So, all right. So yeah, basically what I'm trying to get you to understand here is if you're at T1 or T2, which one's lower temp, which one's higher temp?
T2.
T2 is lower temp.
I said which one is low, which one's higher? You
I
said
said
T2.
I said T2 when you said lower.
Okay. And what do you say?
That's what she
I
said.
just told
What'd
you.
you say?
Wait, is that
she said-
wrong?
I don't know. Well, let's think about it.
Wait.
I didn't think about it. I just saw a lower
Number of
sum.
molecules,
Yeah.
the temperature would be higher with more. No, it'd be lower with more molecules because they have less
Well, when it's faster,
room
it's
to move
more
along,
hot.
move around.
When it's not.
It's faster, it's more hot.
It is.
Okay, fair enough.
And
What happens when particles collide?
collision.
They give up energy.
The
They
energy
transfer
is higher.
energy.
So T1 is higher.
temperature.
So T2 is the higher temperature.
Wait,
I said that, and you.
This would be
you
like
jerk.
100K. This would be like 400K.
Why?
Here's why.
That is what I
If you
said.
have gas contained in some container and it's at a really low temperature, what is there not going to be a lot of?
Collisions.
Right. That means there's going to be a high number of particles at one speed because they're not transferring energy. If they're at a really high temperature, they're transferring energy constantly, that all their speeds start to flatten out. So all the particles start to move at kind of like, the speeds are distributed, so it isn't a whole lot of particles moving at one speed. That's a better way to say it. When they collide, they're transferring their energy, so there isn't a grouping just at one speed because they're constantly transferring and either moving faster or slower. So this one's more equally distributing the speed among molecules. This is all at one speed. One speed, most of the particles. So this one, think of it, it's like flattening. You're like distributing the speed among the particles. So think a number of particles here, right? So there's going to be more particles kind of moving at the same speed versus here, like spread out, versus all of them just at one speed. I didn't say that very well. So that's what you need to know. Higher temp, they transfer energy, so it's distributed. That's the best way to think of it. So there's not going to be a peak. Because if there's a peak, there's not a lot of transfer going on. You have some moving really fast, right? Some moving slow, but most of them moving the same speed. Is that making sense? Because I said it wrong a couple times trying to re-explain it. So those two graphs. What heats up faster, metal or water?
Metal.
Metals. Why?
Because they don't evaporate. Wait.
Because they're just themselves.
Specific heat. Specific heat of metals is really low. Specific heat of water is pretty high, 4.18. You don't need to memorize that. I'm just giving you a little insight. There's a question that you need to at least understand that metals cool off and heat up really fast. Water heats up and cools down really slow. Why?
Yeah.
Because you're going to need to use that.
But
What
you
do you
don't
mean?
use the equation.
You're going to have to use this equation, which I told you last review class.
Yeah.
Anyway. But just, I've read through the test today, and if you don't understand metals heat up very quickly and cool down very quickly, this isn't going to really do you a lot of good.
How do you use that equation to?
So if you know the specific heat, so that's C, and you know the mass, and you know the change in temperature, you can calculate the energy involved with that.
So everything will be given, pretty much?
Yeah, you should be given, and the specific heat of water, I think, is on your equation sheet. 4.18.
Are you giving
Yeah.
us new equation sheets or no?
Everything's brand new. If it's not on there, they'll give it to you in the questions. You don't have to memorize that now. So just one more thing about that though is if you put something in water, a lot of these questions, really?
You were talking about it,
For like maybe 10 minutes.
and then you talked again.
If you put something in water, the test is going to give you the water's change in temperature. But they might be asking about the energy of the substance.
How would you know that?
So the change is substance, right?
So if you put something in water and the water goes from 25 to 50, let's say,
Yeah.
so you can solve for Q using the water's information. Mass of the water, specific heat of water, this would be 25. When you solve for Q for water, that's exactly the same Q of whatever the substance is because of the law of conservation of energy. I guess we are out of time.
Count about that.
Yeah. But we got time tomorrow.
I don't want your